All right, hello class. Today we're going to do our notes on experimental probability, section 1.1. So first, a few vocab words on what does that mean. Okay, well, an experiment is an activity involving chance, such as rolling a dice, or rolling a cube, or also a a dice. So that's an example of an experiment. Anything that you physically do and you calculate the results, that would be your experiment. Okay, the trial is each repetition or observation of the experiment. So when you roll that dice once, that's your first trial. You roll it again, that would be another trial. Okay, the outcome is each result. So for example, rolling the 2. So after you roll it, you see that you have a 2. So that's the outcome we're looking for. Okay, and then the event is a set of one or more outcomes. So your event could just be rolling a 2. It could be rolling an even number. It's whatever we're looking for. All right, so how does this all come together then? So experimental probability then is found by comparing the number of times that an event occurs with the total number of trials. Okay, so you sit there and you keep rolling the dice over and over and over again. So whatever event you want, that's what we would put on the top. Okay, the number of times your event occurs. So if you wanted to roll a 2, you'd say how many times the 2 happened. And on the bottom is the total number of trials. How many times did you conduct your experiment, whatever it was. Okay, so you would write probability of whatever your event is, so such as rolling a 2, and then how many times it happened out of how many total things it is. So maybe put a big bubble around that. Okay, that's what you're going to use. Probability always starts off as a fraction of the things of what you want to happen out of the total. And then you can change it from the fraction into decimals and percents. So that's what we're going to practice in these examples. So I'm going to slide this up. Okay, so we got a few examples here. So find the experimental probabilities. So if you roll a 6-sided die 25 times, and 3 out of those 25 times you roll a 1. What is the experimental probability that the next time you roll the dice, you will get a 1 again? Okay, so we always want to write what is our event. We want to write that we're doing probability of, well, we want to get a 1. So the chance of rolling a 1. Okay, so that's how we write it so that we know what are we looking for. Okay, then in the numerator, we write how many times it occurred in our experiment. Well, it occurred 3 times. Okay, and then on the bottom, we say out of the total. So the total was 25 times. Okay, so the bottom is always a total. The numerator is how many times you got whatever it is you're looking for, how many times you rolled a 1. All right, so that is it as a fraction. If we can reduce the fraction, we would. 3 doesn't go into 25, so I can't reduce it. But I can write it as a decimal and a percent. So we'll grab our calculator then, and we just divide those. 3 divided by 25 gives me 0.12. Okay, that would be the probability as a decimal. And then to make it a percent, remember we just move it 2 spots over. So 1, 2 would be 12% chance. A lot of times people like seeing probability as a percent because you know it's out of 100. It helps you see big picture what the chances of that happening. All right, so next question. Students have checked 55 books from the library. Of these, 32 books are fiction. Okay, we want to find the experimental probability for the next book checked out at the library. All right, so we've got 2 probabilities here. First, we want to find the probability that's fiction, and then the probability that it's not fiction. All right, so first the chance that it's fiction. Well, we know out of these numbers, the 55 is the total, so total always goes on the bottom. And then the 32 is the books that are fiction, so that is what I'm looking for. So I would put 32 out of 55. All right, and then let's see, would that reduce? 5 and 11 go into this, but not that, so we leave it as a fraction, but we can go ahead and make it as a decimal and a percent. So if I do 32 divided by 55, we would get 0.581 repeating. So we'll just, since we're talking percents and stuff, we'll just do 2 decimals every time. So 0.58 would be good. And then we would move it 2 places over to make that a percent, 58%. All right, so that is the probability that it's fiction. So now we want the probability that it's not fiction. Well, let's think about this. If 32 of the 55 books are fiction, to find not fiction, we would just have to take away the 32 from 55. So not fiction would be 55, take away 32, which would be, well, let's see, 23 books. Okay, so 23 books are not fiction out of my total of 55. So 32 are fiction, 23 are not. Okay, now when I divide that, 23 divided by 55, we get 0.418. So it's 0.41, but since there's an 8 after it, we round that up to 0.42, okay? Or 42% when we move our decimal 2 spots over. Okay, I want you to notice something. Whenever we do probability of an event versus the probability of that event not occurring, look at what you notice about these 2%. What happens when we put them together? Well, 58 plus 42 makes 100%. That will always happen when you have an event and a non-event, because the event will either happen or it won't. There's nothing in between. So their probabilities will always total 100%. You would also notice that the decimals, if I put those together, they would total 1 if I add them. Oh, I shouldn't write that there, though. Don't write that. But the total of these would be 1. Let me do like this so it doesn't look like a fraction. Okay, so if I add, it equals 1. And the fraction also, if I add them together, also equals 1. So both the decimals and the fractions would add up to make 1. So we'd add our numerators, makes 55 out of 55, which is 1. All right, so that always happens with an event versus a non-event. All right, we got one last example here. If your team has won 3 out of 10 games that they've played so far, what is the experimental probability that you are going to win the next game? Okay, so I'm writing this. I would say I want the probability of winning. Okay, well, how many times did winning occur? Well, winning occurred 3 times out of a total of 10. All right, which we can't reduce, so we just go ahead then and make it a decimal. If I divide that, 3/10 we know means 0.3. And then to make that a percent, move it 2 spots over. 1, 2, that would be 30% chance. All right, so that is the chance of winning. Now it says, what's the experimental probability that you will lose the next game? Well, that's just the opposite of winning, right? So if we say probability of losing, okay, if we can see that, okay. Well, if we win 3 out of 10 times, we subtract 3 from 10, that means we lost 7 out of 10 times. Okay, and 7 plus 3 totals your 10. Okay, which as a decimal then is 0.7, and then as a percent, move that 2 spots over, is 70%. Okay, notice it happened again just like the other thing. 30% plus 70% makes 100% because you either win or you lose. Again, assuming that we don't have the option of tying, I guess, in this situation. All right, so those are your notes on experimental probability.